Hello, welcome to Lesson on Sampling. This is our first lesson on the topic, and we're going to be looking at systematic sampling. So let's talk surveys. Surveys are used all the time in all aspects of life. They can be used in politics, business, sport, education, and healthcare. And they are used just to get an idea of what people feel about certain topics. Whether in politics and business, it could be used to see how people feel about their business, or it could be see how people are looking to vote politically and coming up to the next election. In sport, people can use surveys to find out what their favorite teams are or who they think is most likely to win a game. And in education and healthcare, a lot of surveys are carried out on staff just to ask how they think their profession is going and how well they think their school, their hospital is being run and what they can do to help it. Also, surveys are also carried out on all staff in all businesses just to see how their well-being is, to make sure they're all okay. And hopefully, when they get the results back, everyone's not doing too bad. But you wouldn't know any of those things unless you carry out surveys. There's two types of surveys. A census is where you survey everyone in the chosen population. Now, that's not so bad if you want to ask every kid in a classroom what's their favorite color. But when the British government want to do a census on every single person in the country, just to get a snapshot of what everyone's doing in the country, that takes a lot of time and effort, and it's a very demanding task to survey every single person in the population. We don't do them very often, but we do them, and they take a lot of time to process. An alternative is sampling, and this is where you simply choose a smaller number of people that you hope represent the larger population. So sampling is a statistical test to find information about a population by observing a smaller proportion of it. We then use the data collected to make an educated guess about the characteristics of the whole population. If we're going to pick a smaller proportion of the population, we need to make sure that we avoid any biases. So a bias is where you would have data and it tends to skew in a certain direction that would mislead you on what your findings are in your survey. For example, if we're going to ask all of year 7 what their favorite sport is, if we only asked the 20 pupils on the football team, that's not going to be very fair, is it? Because clearly the answer will probably be football. Whereas the other 200 kids in year 7, they may hate football, but because we've served those 20, we're clearly going to have a biased response, and our survey isn't going to be right. So there's two methods of trying to ensure that sampling is representative of the population, and that is random and systematic. Random sampling is where people are chosen to take part in a random fashion. This can be done in the fair. Random can be achieved in various ways. You could throw a dartboard. You could throw a dart at a list with loads of names on it. You can roll a dice. You can flip some coins. You can refer to the digits of pi if you just want a random number. But true randomness is actually really hard to achieve. It's so even if you were thinking to yourself, trying to think of a random number between 1 and 10, the answer wouldn't be that random. If we kept on asking that question, some patterns would appear. And for example, if I asked you to think of a vegetable, hope some of you probably thought about a carrot. And I don't know. Hopefully, some of you actually did think of a carrot, because that's a common psychological trick that people, if you ask people to think of a vegetable, they tend to think of a carrot. That's not magic. That's just human nature. For some reason, when we try to think of a random vegetable, a lot of people come to carrot. So it's really hard to actually be random. And that's why random sampling is quite hard, because it's never, if you're saying you're doing a random sample, you have to actually prove that you've picked people randomly, and that can be quite hard. Systematic sampling, on the other hand, is relatively easy. All you do is you start at a random point in your population, and participants are then chosen at fixed periodic intervals. For example, you decide that you're going to pick every 10th person. So you go through, you number everyone between 1 and 100, say, and you go through that list and you just pick every 10th person. And it's not random though, because we're using that fixed interval size, there's still some scope for some biases to appear. But it's much better, it's much easier to carry out than random sampling. And while there is a chance that it may be less representative of a population than a random sample, it's good enough. It's the effort and reward pay. If you weigh up how much effort it takes to the results you get back, it's actually worth doing. So how do we do this? Well, if we have 20 students in a year group, I want to carry out a systematic sample of 4 pupils. Describe how you would do this and state the interval size. So the first step, there's only 2 steps to this. First step, we need to number the pupils 1 to 20, because there's 20 pupils. And the next step, we need to pick we need to pick every person that are 5th, 10th, 20th. We don't know the number yet, but we can figure it out using this information we've got here. Okay, so to figure out the interval size, we do the population divided by sample size. Sample size, and that will give us our interval size. Okay, so just like that. In this case, our population is 20, our sample size is 4, 20 divided by 4 is 5. So therefore, our interval size, and then you pick pupils using an interval size of, of 5. Okay, job done. Number the pupils 1 to 20, and they're going to pick pupils using an interval size of 5. Job done, easy peasy. Next question. There are 100 students in a year group. I want to carry out a systematic sample of 5 pupils. Describe how you would do this and state the interval size. So 1, I'm going to number my pupils 1 to 100. Number pupils 1 to 100. 2, I need to find the interval size. That's easy. We can do this. Population divided by sample size. So that's going to be, equals interval size. Getting ahead of myself. So that will be 100 divided by 5. 100 divided by 5 is 20. Therefore, we're going to pick pupils using an interval size of 20. Okay, job done. Let's do one more example. There are 140 students in the year group. I want to carry out a systematic sample of 35 pupils. Describe how you would do this and state the interval size. So here we go again. 1, number pupils 1 to 100. 1 to 140. 1 to 140. 2, we need to know the interval size. Here we go again. Population divided by sample size equals interval size. So therefore 140 divided by 35, and you would get 4. So therefore, we're going to pick pupils using an interval size of 4. Just like that, easy peasy. All right, let's have a look at the main task now. So here are your questions. So for the first question, the others are fairly easy to follow, but the very first question, you need to select a systematic sample of size 10 from the class and 6 from the class. I then want you to give me the names of the pupils who you pick in your systematic sample. Okay, so every time you're going to start from Alan, but you're not going to include Alan. Okay, so Alan's if you're counting every 5th or 6th person, Alan is the first. Alan is he's the first number you count, but he's not the first person you're going to include in your sample. Okay, so for example, if I have an interval size of 4, if I have an IS of 4, I would pick 1, 2, 3, 4. I would pick Azar. 1, 2, 3, 4. I'd pick Sushi. 1, 2, 3, 4. I'd pick Emma, and I would keep going until I've met the number of people that they want me to pick from the class. Okay. So pause the video and have a go with these questions. Best of luck. Okay, here are the answers. Very well done if you got those right. And for question 3, a bit of a trick. You don't need to number the houses because they're already numbered for you. So how about that? Okay, so let's have a look at the checking question now. So here's the checking question. I have created a systematic sample of a group of students, but I lost the list, so I can't remember how many pupils there were. I remember that I wanted a sample size of 18 pupils, and the interval size was 5 pupils. How many pupils were there originally? So pause the video and have a think. How many pupils were there originally if I wanted a sample size of 18 and the interval size was 5? Okay, have a little think. Pause the video, have a go. Okay, so if we remember the formula for interval size, it was population divided by sample size. I'm just going to call it sample. And that was equal to the interval. Okay, so we know 2 of these values. So we know population. So we don't know population. We know the sample is 18, and we know the interval is 5. So how can we rearrange this? Well, if we think about it, we can just think about, you can use algebra for this. If we just take population, if we imagine it was just a letter like P or X or anything like that, how would we get this P on its own? Well, we would have to multiply both sides by 18. And that would give us, the 18 would cancel out below the population, and it would equal 5 times 18. And 5 times 18 is 90. So there were 19 pupils originally. Okay, so just a bit of rearranging some formulas, okay? Good, I hope you found the lesson okay. Nice easy one, that one. And I'll look forward to seeing you next time. Bye now.